Hi guys, in this video I will show you how to implement a simple symbol table for our calculator, because the next version of our calculator will support variables. And of course, later we will reuse the ideas of this simple symbol table for our compiler project. So the next version of the calculator will support expression assignments, where on the left hand side of the equal sign, this will be our operator for the assignment, you need to have a variable. Variables will be the only L values that we allow. Then the right hand side gets evaluated and this value gets assigned to a variable, and variables will be realized with these symbols. If a variable wasn't used so far, this symbol will not exist. Then we have to generate a symbol for this variable, in this case for the identifier x, and then assign to it, in this case, the value 10. That means afterwards we have a symbol for this variable with value 10, and then we can use it in another expression like here. Then now the right hand side has the value 12, and this value gets assigned to an already existing variable. That means the symbol already exists. We simply override its value to 12. Now if you use another expression like here, the right hand side now would have the value 25. The left hand side is a variable that wasn't used so far. So again, we have to create a new symbol for it and then assign to it the value 25. So I think you get the idea. But then we have to agree on how to treat the case where you have an unknown identifier on the right hand side. That means a variable that wasn't used so far. And then we have to agree on whether we allow this or say this is an error. And for simplicity, we will actually allow this. So that means we will generate a new entry for this variable, and it will have a default value, a value of 0. And now we would have three variables, x, y, and a would have the value 0. So variables will be realized with symbols, and a symbol is simply a pair of an identifier and a value, the current value of this variable. So we declare for that a struct with two members. The identifier will be a unique string. It should not be possible to change the identifier of a symbol once it's created. You cannot change the string stored in a unique string anyway, but it also should not be possible to redirect this pointer, this identifier, this first member of this struct. That's why we have this const qualifier also here. So this cannot be changed, but of course you can change the value of the variable. The symbol table simply will be a pool of unique symbols. That means for a given identifier you can have exactly one symbol, and there will be two functions for using the symbol table. One function, symadd, can be used for adding a new symbol for a given identifier. If a symbol with this identifier already exists, then this will be not an error. This simply means that this function will return a pointer to this already existing symbol. And otherwise a new symbol gets created with default value 0. Then another function, symFind, can be used for looking up a symbol for a given identifier. If this symbol actually exists, you get back a pointer to this symbol, and otherwise the null pointer. So that means if you want to have, in the case of an unknown identifier, a new symbol with default value 0, you have to combine these two functions. Okay, now let's implement this symbol table. So the typical workflow, I first want to have some test, at least some minimalistic test before I begin with the implementation. And then I think about some typical use cases. I want to assign some value to a new symbol. Then I want to change the value of the symbol. And then I want to assign a value to another new symbol. And after that I want to look up some symbols. So for that I will implement a auxiliary function or assign or insert. In this case it will generate for this identifier x a new symbol with value 42, and here it should just change the value of an existing symbol. Change it to 2, and here I want to have another new symbol for the identifier y, and here I have the value 5. And then I simply want to look up some identifiers in the symbol table. Of course, the identifiers from above, and maybe another one which will not be found. Okay, and then I need certainly standard I/O for printf, and of course the header for the symbol table and for the unique strings. And then I first write this skeletons for these two auxiliary functions. So assign or insert gets first a const pointer to a unique string identifier, and double is the type for the value. And then this second function, lookup, just gets a const pointer to a unique string. And this actually can be written in just one line. This sym add returns a pointer to a symbol, and this just gets dereferenced, and the member value gets the value from the parameters. And here I first do a lookup by calling this sym find, and if this is not the null pointer, then I want to print out the value of the symbol. So that's found identifier C string. Actually, identifier C string would have had the same effect. And found value. Okay, and otherwise I want to print that the symbol was not defined. So here I have to use identifier C string. Okay. And now I can start with the implementation. And in a first implementation for this symbol table, I just use a list for storing the symbols. Let me first copy these two declarations into the source file. And then I first include the header file. And then I can turn these declarations into function definitions, into skeletons first. And then I already can check whether I can compile everything. So of course with warnings, because these skeletons do not return anything. Okay, but the setting seems to be okay. And then I can begin with a declaration for a list node, a SymTab node, and as usual, this first has a pointer to the next list node, and after that the list element, and then I also need a pointer to the head of the list, pointer to the first list node, SymTab. And then in SymAdd I first check whether this identifier is the null pointer. So I also have to include a cert. And certainly also I need standard lib for malloc. And then I first can check whether this identifier is already used for a symbol. So I simply call symFind, and if this returns something different from the null pointer, then I'm already done. Then I simply return found. And otherwise we have to allocate a new list node. So here the usual pattern. In malloc, this size of the dereferenced pointer to this block. So if this is the null pointer, then we have to print an error message and exit with execute 1. So that means I also need to include standard I/O. Okay, but otherwise we have to initialize this list element. And here you will see this constness of this identifier will cause a problem. And I mean this const on the right hand side of this asterisk. Because that means I cannot redirect this pointer. That means I cannot redirect it to the identifier. The type that I would need on the left hand side would be this type here. The problem is that the result of a cast is not a L value. It's not allowed to be on the left hand side. But what is allowed to be a L value is a dereference pointer. So what I do is I first take the address of this identifier and then I do the cast and then I dereference things. And then you know this trick, because otherwise we get this error if we compile with these warnings for this const cast. So that means I also need to include standard integers. And I want to have this here alphabetically. Okay. Okay, and after that we also have to initialize the value with some default value. And that's actually something that wasn't tested in this test program before. So before I forget it, let me add a test to that after this assignment and before the lookup. Add a symbol with default value. And then I also want to see that this was actually added with the default value. Okay, and then we can continue. The next thing that we have to do is we have to prepend this to the list. That means the next list node will be the list node that was so far the head of the list, and the new head is this new node. And then I simply return a pointer to the symbol. And then sim find. I simply traverse the list. And otherwise, if we haven't found it, we will return a null pointer. And in the list, I simply now compare the pointers of the unique strings. So this saves us this string compare. And if we found this identifier in this list, then we simply return the address to its symbol. Okay, and now we can check this. Okay, this of course should be n sim identifier. And then above the typical C programmer mistake, in C you need this struct keyword here. Now let's see. Okay, compiles, and this minimalistic test at least works. But I also saw something in symfind. I did not check whether this identifier is the null pointer or not. So I want to have an assert here. Okay, let's compile again to see whether there are typos added. No, not the case, and it's still working. That's it for this video. In the next step we will use the symbol table for updating our calculator, but there is something on the to-do list. The symbol table never releases memory. And in our case this is kind of okay, because we need the symbols until the program terminates, and then we have an operating system that releases all the memory of the process that terminates. But this is not a clean design pattern. You always should write programs that release all memory that was allocated. But we will think about that afterwards, how to clean that up. We have the same issue for the pool of unique strings anyway.